Welcome to Huberman Lab Essentials, where we revisit past episodes for the most potent and actionable science-based tools for mental health, physical health, and performance. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. This podcast is separate from my teaching and research roles at Stanford. It is, however, part of my desire and effort to bring zero-cost to consumer information about science and science-related tools to the general public. Today, I want to talk about something that is vitally important, not just for athletic performance, but for your entire life and indeed for your longevity, and that's muscle. One of the things that's exquisite and fantastic about the human brain is that it can direct all sorts of different kinds of movement, different speeds of movement, and movement of different durations. All of that is governed by the relationship between the nervous system, neurons, and their connections to muscle. Today, as always, we're going to talk a little bit of mechanism. I'm going to explain how neurons control muscle. We will touch on some nutritional themes and how that relates to muscle, in particular a specific amino acid that, if it's available in your bloodstream frequently enough and at sufficient levels, can help you build and improve the quality of muscle. We are also going to talk about recovery. That's when muscle grows. That's when muscle gets more flexible. None of that actually happens during training. It happens after training. Most people, when they hear the word muscle, they just think about strength. Of course, muscles are involved in everything that we do. They are involved in speaking. They're involved in sitting and standing up. They're involved in lifting objects, including ourselves. They are absolutely essential for maintaining how we breathe. They're absolutely essential for ambulation, for moving, and for skills of any kind. When we think about muscle, we don't just want to think about muscle, the meat that is muscle, but what controls that muscle. No surprise, what controls muscle is the nervous system. The nervous system does that through three main nodes of control. Basically, we have upper motor neurons in our motor cortex. Those are in our skull. Those are involved in deliberate movement. Those upper motor neurons send signals down to my spinal cord, where there are two categories of neurons. One are the lower motor neurons. Those lower motor neurons send little wires that we call axons out to our muscles and cause those muscles to contract. They do that by dumping chemicals onto the muscle. In fact, the chemical is acetylcholine. Now there's another category of neurons in the spinal cord called central pattern generators, or CPGs. Those are involved in rhythmic movements. Anytime we're walking or doing something where we don't have to think about it to do it deliberately, it's just happening reflexively. That involves central pattern generators and motor neurons. Anytime we're doing something deliberately, the top-down control, as we call it, from the upper motor neurons comes in and takes control of that system. It's really simple. You've only got three ingredients. You've got the upper motor neurons, the lower motor neurons, and, for rhythmic movements that are reflexive, you've also got the central pattern generators. I'd now like to shift our attention to how to use specific aspects of muscular contraction to improve muscle hypertrophy, muscle growth, as well as improving muscle strength. There are a lot of reasons to want to get stronger. I should just mention that it's not always the case that getting stronger involves muscles getting bigger. There are ways for muscles to get stronger without getting bigger. However, increasing the size of a muscle almost inevitably increases the strength of that muscle, at least to some degree. Reasons why most everyone should want to get their muscles stronger are that muscles are generally getting progressively weaker across the lifespan. When I say getting stronger, it's not necessarily about being able to move increasing amounts of weight in the gym, but rather to offset some of the normal decline in strength and posture, and the ability to generate a large range of movement safely that occurs as we age. There's an important principle of muscle physiology called the Henneman size principle. The Henneman size principle essentially says that we recruit what are called motor units. Motor units are just the connections between nerve and muscle in a pattern that staircases from low threshold to high threshold. What this means is when you pick up something that is light, you're going to use the minimum amount of nerve-to-muscle energy in order to move that thing. Likewise, when you pick up an object that's heavy, you're going to use the minimum amount of nerve-to-muscle connectivity and energy in order to move that object. It's basically a conservation of energy principle. Now, if you continue to exert effort of movement, what will happen is you will tend to recruit more and more motor units with time. As you recruit more and more of these motor units, these connections between these lower motor neurons and muscle, that's when you start to get changes in the muscle. That's when you open the gate for the potential for the muscles to get stronger and to get larger. The way this process works has been badly misunderstood in the online literature of weight training and bodybuilding, and even in sports physiology. The Henneman size principle is a foundational principle within muscle physiology, but many people have come to interpret it by saying that the way to recruit high-threshold motor units, the ones that are hard to get to, is to just use heavy weights. That's actually not the case. As we'll talk about, the research supports that weights in a very large range of a percentage of your maximum, anywhere from 30 to 80%, weights that are not very light but are moderately light to heavy, can cause changes in the connections between nerve and muscle that lead to muscle strength and muscle hypertrophy. Put differently, heavy weights can help build muscle and strength, but they are not required. What one has to do is adhere to a certain number of parameters, just a couple of key variables that I'll spell out for you. If you do that, you can greatly increase muscle hypertrophy, muscle size, and/or muscle strength, if that's what you want to do. You don't necessarily have to use heavy weights in order to do that. Now, I'm sure the powerlifters and the people that like to move heavy weights around will say, no, if you want to get strong, you absolutely have to lift heavy weights. That might be true if you want to get very strong, but for most people who are interested in supporting their musculature, such that they offset any age-related decline in strength or in increasing hypertrophy and strength to some degree, there really isn't a need to use the heaviest weights possible in order to build strength and muscle. There are three major stimuli for changing the way that muscle works and making muscles stronger, larger, or better in some way. Those are stress, tension, and damage. Those three things don't necessarily all have to be present, but stress of some kind has to exist. This is very reminiscent of neuroplasticity in the brain. There is a good predictor of how well or how efficient you will be in building the strength and/or, if you like, the size of a given muscle. It has everything to do with those upper motor neurons that are involved in deliberate control of muscle. You can actually do this test right now. You can just march across your body mentally and see whether or not you can independently contract any or all of your muscles. Because everything about muscle hypertrophy, about stimulating muscle growth, is about generating isolated contractions, about challenging specific muscles in a very unnatural way. Whereas with strength, it's about using musculature as a system, moving weights, moving resistance, moving the body. The specific goal of hypertrophy is to isolate specific nerve-to-muscle pathways so that you stimulate the chemical and signaling transduction events in muscles so that those muscles respond by getting larger. There's a critical distinction in terms of getting stronger versus trying to get muscles to be larger, hypertrophy per se. It has to do with how much you isolate those muscles. You can nest this as a principle for yourself, which is, if you want to get stronger, it's really about moving progressively greater loads or increasing the amount of weight that you move. Whereas, if you're specifically interested in generating hypertrophy, it's all about trying to generate those really hard, almost painful, localized contractions of muscle. If ever there was an area of practical science that was very confused, very controversial, and almost combative at times, it would be this issue of how best to train. I suppose the only thing that's even more barbed wire of a conversation than that is how best to eat for health. Those seem to be the two most common areas of online battle. What's very clear now from all the literature is that once roughly your 1 repetition maximum, the maximum amount of weight that you can perform an exercise with for 1 repetition in good form, full range of motion, that it's very clear that moving weights or using bands or using body weight, for instance, in the 30 to 80% of 1 rep maximum, that is going to be the most beneficial range in terms of muscle hypertrophy and strength, muscle growth and strength. Let's say you're somebody who's been doing some resistance exercise on and off over the years, and you decide you want to get serious about that for the sake of sport or offsetting age-related declines in strength. The range of sets to do in order to improve strength ranges anywhere from 2, believe it or not, to 20 per week. Again, these are sets per week, and they don't necessarily all have to be performed in the same weight training session. It appears that 5 sets per week in this 30% to 80% of the one repetition maximum range is what's required just to maintain your muscle. Think about that. If you're somebody who's averse to resistance training, you are going to lose muscle size and strength, your metabolism will drop, your posture will get worse, everything in the context of nerve to muscle connectivity will get worse over time. Unless you are generating 5 sets or more of this 30% to 80% of your one repetition maximum per week. What this means is, for the typical person who hasn't done a lot of weight training, you need to do at least 5 sets per muscle group. Now that's just to maintain. Then there's this huge range that goes all the way up to 15 and in some cases 20 sets per week. Now, how many sets you perform is going to depend on the intensity of the work that you perform. This is where it gets a little bit controversial, but I think nowadays most people agree that 10% of the sets of a given workout, or 10% of workouts overall, should be of the high-intensity sort where one is actually working to muscular failure. The point being that most of your training, most of your sets, should be not to failure. The reason for that is it allows you to do more volume of work. We can make this simple. Perform anywhere from 5 to 15 sets of resistance exercise per week. That's per muscle. That's in this 30 to 80% of your one repetition maximum. That seems to be the most scientifically supported way of offsetting any decline in muscle strength. Please do keep in mind Henneman's size principle and the recruitment of motor units. Remember, the better you are at contracting particular muscles and isolating those muscles, the fewer sets, likely, you need to do in order to get the desired effect. What about people who have been training for a while? If you're somebody who's been doing weight training for a while, the data point to the fact that more volume can be beneficial, even for muscles that you are very efficient at contracting. Now, the curve on this, the graph on this, begins again at about 5 sets per week for maintaining a given muscle group and extends all the way out to 25 or 30 sets per week. However, there are individuals who, for whatever reason, can generate so much force. They're so good at training muscles that they can generate so much force in just 4 or 6 or 8 sets that doing this large volume of work is actually going to be counterproductive. Everyone needs to figure out for themselves, first of all, how often you're willing to do resistance exercise of any kind. Then, it does appear that somewhere between 5 and 15 sets per week is going to be the thing that's going to work for most people. Now, this is based on a tremendous amount of work that was done by Andy Galpin and colleagues, Brad Schoenfield and colleagues, Mike Roberts, and a huge group of people out there doing exercise physiology, and a small subset of them linking them back to real-world protocols that don't just pertain to athletes. That's mainly what I'm focusing on today. Surely, there will be exceptions. Now, if you are going to divide the sets across the week, you're not going to do all 10 sets, for instance, for a given muscle group in one session, then of course it's imperative that the muscles recover in between sessions. You might ask, well, what about the speeds of movements? This actually turns out to be a really interesting data set. For generating explosiveness and speed, it's very clear that learning to generate forces quickly and to move heavy or moderately heavy loads quickly is going to be beneficial because of the way that you train the motor neurons and, of course, changes in the muscle. What this would involve is something like 60 to 75% of one repetition maximum, and then, in a controlled way, moving that as quickly as one can throughout the entire set, and certainly not going to failure, because as you approach failure, the inability to move the weight with good form means the weight inevitably slows down. As you're probably starting to realize, you need to customize a resistance practice for your particular needs and goals. Now, how long to recover between sets? For hypertrophy and for strength gains, it does seem that resting anywhere from 2 minutes or even 3 or 4, even 5 or 6 minutes, can be beneficial. How do we know if we've recovered? How can we test recovery? You can assess systemic recovery, meaning your nervous system and your nervous system's ability to generate force, through simple tests like grip strength and carbon dioxide tolerance. Grip strength is a powerful indicator of your nervous system's readiness. If your grip strength is significantly reduced compared to your baseline, it may indicate incomplete recovery. The carbon dioxide tolerance test is another useful tool. By measuring how long you can slowly exhale after a full inhale, you can gauge your recovery state. Short times may indicate poor recovery, while longer times suggest readiness for more work. Recovery is a complex process, but these tools can help guide your decisions. Finally, let's talk about some key factors that support muscle performance. Salt is critical for nerve-to-muscle communication. Without sufficient sodium, neurons cannot fire properly. You also need adequate potassium and magnesium. Creatine has been shown in numerous studies to improve power output, hydration, and reduce fatigue. A typical recommendation is about 5 grams per day. Leucine, an essential amino acid, plays a major role in muscle repair and growth. Getting sufficient protein from whole foods is generally recommended. The simple takeaway is to eat 2 to 4 times per day and ensure you're getting enough amino acids to support muscle repair and growth. Last but not least, I want to thank you for your time and attention today. As always, thank you for your interest in science.